Hi class, how are you? Hope you and your family and loved ones are all doing okay and staying safe. Now we're going to talk about chi-square goodness of fit test today. And we're going to talk about what it is. We'll hop over to RStudio for a demo. And then it'll be your turn to try your hand at running this particular analysis in RStudio. So let's get started. So you're already familiar with this slide. So now you know that we are going to be on the second part of the chi-square tests series, and you will be testing how the distribution of categories for your variable matches a particular population distribution. So this is a goodness of fit test. So for the chi-square goodness of fit test, you need one categorical variable. And you may be wondering, what am I supposed to do with just one variable? Well, what you're doing with it is that you're going to look at the distribution of the categories or levels inside that variable, the observed distribution in other words, and then comparing that against a known population distribution. And so for example, let's say that you surveyed 100 college students and asked what their favorite pet type was. You gave them 4 options: dogs, cats, birds, and reptiles, and you tally the number of people who identified one of those 4. And so everyone falls into one of these 4 categories. And so this is the observed distribution, what you got out of the data. And let's say that your hypothesized distribution or the expected frequencies are that equal numbers of people chose each pet type. And so you have an even distribution across these 4 categories. And let's translate that into hypotheses. And so the null hypothesis would say that the students' favorite pet types are distributed the same as these expected frequencies like this. So in this case, it's an even distribution where each category has the same number or the expected frequency. So you're saying that the observed frequencies are not significantly different from this table. The alternate hypothesis says that students' favorite pet types are distributed significantly differently from this population distribution. So you're saying that what I found in my data is different from this. Now, when you run the goodness of fit test, you think in terms of proportions more than the actual expected frequencies, and you will see that when we transition over to RStudio. And so let me just quickly show you how you would derive the proportions. And so the total n here is 100. And for each of these categories, you want to think about the proportion or the percentage of the expected frequency that goes into that category. So in this case, there are 25 dogs out of 100, and so the expected proportion is 0.25. And of course, you would repeat that because all of these are evenly distributed, have the same expected frequency, and so the same expected proportions. But should these numbers change, then you would update them, of course, by updating the numerator and then using the same denominator, which is the total n for each of these categories. And so you want to know the expected proportion for each category or level within your variable before you get started in RStudio. So here's your good old friend chi-square. And so for each cell, once again, you take the difference between your observed frequency, so what fell into that cell, minus the expected frequency, and then square that difference, divide that by the expected frequency again, and then sum all of that up across the different cells that you have. Now this time expected frequencies can be the equal frequency, which is often the default, or the expected population frequency based on the known population distribution. And then degrees of freedom in this case is a bit different. This time you just look at the number of categories that you have minus 1. So let's go to RStudio to run our test. Now you will see that we're going to use a chi-square test function again. In the goodness of fit test, the arguments that go inside the parentheses look a little different. And so first you tell RStudio what the observed frequencies were for your variable that you're trying to test. And then in the latter part of the expression, using p equals and then the expected proportions, you tell RStudio what your population proportions are. And so let's hop on over to RStudio and see how that's done when you enter information by hand. Alright, so here we are in RStudio. I've started to prepare my working environment by setting the working directory and so on. But first of all, let's try entering our information by hand. And so I'm going to start writing down code here. And so first of all, what we want to tell RStudio is the observed frequencies. And so I'm gonna name the destination data object pets. And then do you remember how to make a list of numbers? You may be thinking, yes, use the concatenate function. And so you're absolutely right. And we want to write down the observed frequencies for the variable related to the favorite pet type. Now, based on the table that we have from the lecture slides, I have 30, 30, 20, and 20. Whoops. And so in this case, it corresponds to dogs, cats, birds, and reptiles, and that was the observed distribution. And so you can run that code and create a vector or a list of numeric information called pets. And so it showed up right here in the environment. And so if you were curious about what's inside pets, of course, you can ask it to print, and you have that list over here. Now, you also want to tell RStudio the expected proportions or the population distribution for these 4 categories. And so let's say I wanted to call that ePets, expected proportions for pets. And so maybe I should write down notes here though before I finish the code. All right, so now I've written down notes saying that this is the numeric list of the observed frequencies called pets. Now we're going to create a vector called ePets, which tells RStudio the expected proportions. And you can still do that using the concatenate function, but this time instead of the expected frequencies, you want to enter the expected proportions. And so the proportions would be all 25% or 0.25. Now you can also do 0.25 if this is easier to understand and read, and so feel free to do that. It's the same number. And so 25% for dogs, cats, birds, and reptiles in the same order. And so let's try running that. Okay, so now we have ePets. And so now we have the vector of observed frequencies and then a vector of expected proportions, and we're ready to run the chi-square test. And so you can do that using the chi-square test function again. But this time, you want to insert pets as the observed frequencies information. And then here you want to tell RStudio what to use as expected proportions. And don't forget the p equals to let RStudio know that this is the expected proportions. Whoops. ePets. And so let's try running that. Ta-da! And so now we have the results of the chi-square test. And what we notice, the p-value is 0.26. And so that's greater than 0.05, which means that we do not reject the null hypothesis. So it appears that the distribution we had in the actual data, 30, 30, 20, 20, appeared to be statistically the same as having an even distribution where the 4 categories are distributed 25 each. And so that's how you run a chi-square test when you enter the information, the observed frequencies, and the expected proportions by hand. But what happens when we have a data set to work off from? Let's take a look at that type of example now. And so now we're going to work off from a data set called demographics, which you can download as an Excel spreadsheet or workbook from Canvas. And let's say that we had this research question. Are the participants in the sample evenly distributed across class years or standings? And so let's begin to explore that question in RStudio. Welcome back. So here you probably would notice by looking at my environment area that I've already read in the demographics Excel sheet. And so you can take a look at the fact that there are 2 variables. You can also use the viewer to check out the information contained here. And so there is the variable school, and then there's the variable year. And if you're curious about the distribution within year, which is the variable that we're going to work with, then you can certainly try to run crosstabs or table. And so just to recall, crosstabs, whoops, you could run like this. And you will see as we go that you could also use the table function to get a tabular, whoops. There you go. So table function, but for table function you use the tilde. Here we go. And so made myself an error, but we fixed it. Hooray! And so what this tells you that there are 4 levels of this variable year. And so there's freshman, junior, senior, and sophomore. Now this probably is making your eyes cross a little bit because RStudio is actually alphabetizing these categories. And so when you look at the list of categories or levels here, you really want to be careful to pay attention to how RStudio is organizing it. In this case, it appears alphabetical to me. And so not the way we might conceptualize it in terms of freshman, sophomore, junior, and senior. So be careful. Make sure to keep that ordering in mind when you work in RStudio. Woo! Always an adventure, isn't it? Alright, so using my instantaneous typing skills, I have now begun a new set of notes for our current chi-square goodness of fit test, where we want to enter frequencies as table, and so I will show you what I mean shortly. Now, something that we might want to do is to take a subset of demographics so that RStudio can focus on year, and that would make our lives easier actually. So let me show you how to save a dataset where you only have a year so that you can have RStudio focus on it. So let's say that you want to call that subset dataset year. Then you can actually use the subset function again. And in order to do that, you want to tell RStudio first of all which dataset you're taking the subset from, in which case this is demographics, of course. And then last time we chose by cases. This time we want to choose by the variable. And in order to do that, you can tell RStudio to select by the variable name. And so it recognizes once you say it's demographics that is one possibility. Alright, so let's try running it. Took RStudio suggestion, trusted it too soon. That's year. Remember how RStudio is sensitive to capitalization? So here we go, and it looks like now it looks good. And then you can also see here that there's another smaller data set with just the variable year. Feel free to explore it if you like. So you can do table, and you get the same results as what you saw before. So that subset function worked very nicely. You can also view, if you like, since this is a data frame, it will open up in this very nice new window, and you can also compare to see if it saved properly, sophomore, junior, and that looks pretty good. It looks like that saved accurately. And so here are a couple ways to kind of explore what you just saved or as a subset. And so what we want to do is to save the table of frequencies like this into RStudio so that it can be used inside the chi-square test. And in order to do that, you can create another object. And so let's say that I wanted to call it table. Whoa, that is not what I wanted to type. Table year. And you can ask RStudio to save the table that you had of frequencies, observed frequencies, inside this object table year. If you're curious about what it looks like, you can also ask it to print, and here it is. And table year can be now read into our favorite chi-square test. All right. And so once again, we have the friend chi-square test. And this time we want to tell chi-square test to be run on this table year that you just created. And then the proportions you want to enter here, as you might remember from the p equals sign. And in this case, we want to test to see if the classes are distributed evenly, and there are 4 classes. And so the proportions, once again, would be actually 25% each, or 0.25 each. And so in this case, though, you want to remember that it's going in freshman, junior, senior, sophomore. Now, of course, in this instance, you don't necessarily need to remember too hard because the proportions are equal. But if you have different proportions, then you want to make sure that it's in the same order as what RStudio is going to understand your table data. So freshman, junior, senior, and sophomore. And so you're saying that the expected proportions are quarter, 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 or 25%, 25%, 25%, 40% for each of these 4 years. And so we run that chi-square test. And then we get the results. Now getting the numbers is all well and good, but we have to be able to interpret it, right? And so let's hop on over to PowerPoint to discuss what we found with this particular test. Alright, so I have transferred our results here. And what you notice first and foremost is general result. And so the p-value is 0.009. And so you notice that the p-value is less than your alpha of 0.05, which means that you reject the null hypothesis. Now what does it mean to reject the null hypothesis? To reject the null hypothesis would say that your observed frequencies is different from the population frequencies in the expected distribution, right? So there is actually a difference between what you found, observed, versus what you expected, which is a proportion distribution. Here's one translation of it. So you might say that the sample was not evenly distributed in terms of the student's class or academic standing. So freshman, sophomore, and so on, those 4 years. You tested your data against the expectation that those 4 years had the same distribution or frequencies. And your data happened to diverge from that. It was significantly different from that expected distribution. And so now you can say that essentially the sample size within each of those class years were not all the same, that there was some sort of a difference across those 4 different years. And then you can write up your chi-square test results as before like this. So that was fun. So now, following the procedures that you saw in lecture, please test the following research questions using both of the variables in demographics. So let's say that for the first question, you're now using variable year again. And I'm asking you, does the sample have the following distribution? So I've given you the proportions expected for these 4 different classes. And so go ahead and run your chi-square goodness of fit test to see if the actual data is the same or different from this particular distribution. And be careful when you enter the proportions, because RStudio is not going to enter the data in this particular order. Remember that they organize it by the alphabetical order. And so be very careful that when you enter your expected proportions, that they go in the same order that RStudio is treating these levels. And then the second question is for the other variable, school. The school variable has only 2 values, CSUF and other, and the school variable tells you which school the student came from. And the research question for you is, are there same or equal proportions of students, so essentially 50%, 50%, from CSUF and other in this sample? And so go ahead and see if you can test that as well. And look forward to hearing about your results. And of course, please feel free to post any questions you may have on Canvas. And keep in mind, if you only have categorical variables, then chi-square or b-square. That was pretty bad, wasn't it? Anyway, have a great week and take care. It's been good spending time with you guys. See you next time.